Imagine the future you were promised. Like, just think back to 1969 for a second.
Right, a pretty big year for progress.
Yeah, exactly. That was the year humanity landed on the moon for the very first time. And it was the exact same year the Concorde, the commercial passenger jet flying faster than the speed of sound took its very first flight.
Right.
So the trajectory back then just seemed completely obvious. We were supposed to be getting faster.
Literally, the world was supposed to be shrinking.
Exactly. Giving us more time, more access, more connection.
It was a very linear expectation of progress. Like you break the sound barrier, then you go to the moon, and the next logical step is that everyday physical life just keeps accelerating.
Right. But let's pull back to reality and look at today. Just recently, it was reported that it takes Lockheed Martin more than 2 years to build a single new Patriot missile interceptor.
Wow.
Yeah. And if you look at commercial flight, Boeing's 787, which is supposed to be this modern marvel, it flies no faster than the Boeing 707 did half a century ago.
It's just the definition of technological stagnation in the physical world. I mean, we lost the ability to go fast, and honestly, we lost the ability to build complex physical things at any reasonable speed.
Yeah.
The software world ate everything, and hardware just sort of fell asleep.
Which is exactly why today's deep dive is so critical. We are extracting the ultimate playbook on business strategy, growth tactics, and deal mechanics from a software engineer who looked at that physical stagnation and just decided to build a supersonic airliner.
Yeah, it's quite the pivot.
Seriously, we're looking at a presentation given at Y Combinator by Blake Skoll. He's the founder of Boom Supersonic.
And what's really fascinating about this source material is that it's not actually a story about aerodynamics.
No.
It's really a masterclass in how to finance the impossible.
Yeah.
How to hack physical iteration and how to build scale in a hardware industry that has essentially been stagnant for 50 years.
Yeah.
The blueprint for founders and builders.
Totally. And if you're listening to this, you've probably felt bogged down by bureaucratic slowdowns in your own work.
Oh, absolutely.
You send an email, you wait a week for a reply, you navigate like 5 layers of approvals just to change a font size on a project.
Right, the endless red tape.
So the sheer audacity of someone saying, I'm going to speed up the entire world by building a mock speed jet is incredibly relatable. But before we get into the how, I have to ask about the why.
Okay, sure.
If the demand for speed is so obvious, why aren't the incumbent giants, the Boeings and Airbuses of the world, why aren't they doing this?
Well, to understand that market failure, you first have to understand the macroeconomics of speed.
Right.
Speed isn't just about convenience, it fundamentally alters the global economy. When the first jetliners were introduced back in the late 50s and 60s, they effectively doubled global speed.
Right.
And that didn't just mean a shorter flight for people who were already traveling.
Yeah, the sources highlight some wild examples of this. Like before the jet age, Hawaii simply was not a mainstream tourist destination.
Right, it took entirely too long to get there.
Exactly. The jet airliner turned this grueling multi-day journey into, a 7 or 8 hour flight?
Yeah, which literally created an entire tourism economy out of thin air.
It's crazy.
And look at global trade, too. Phil Knight, the founder of Nike, he discovered Japanese-style running shoes on a trip to Japan in the 1960s.
Right.
That trip was made feasible by modern air travel. Nike essentially started by importing those shoes to America.
Right, and you also have cultural shifts. Like the Beatles' first world tour simply would not have been practical with those slower propeller planes.
Exactly. So Skoll asks, what would happen if we doubled it again?
Yeah.
What if you could cross the Atlantic in 3.5 hours? What if Sydney, Australia was as easy to get to as Honolulu is today?
I mean, it sounds like a license to print money.
It does. But here is where the incumbent business models really explain the stagnation. Like take Gulfstream, for example.
Yeah.
They cater to the wealthiest people on the planet. People who value their time above literally everything else. So why wouldn't Gulfstream build a supersonic private jet?
Because of the regulations, right?
Exactly. After the Concorde era, supersonic flight over land was banned in the U.S.
Because of the noise of the sonic boom.
Right. So Gulfstream looked at that regulatory risk and just walked away.
But what about Boeing? I mean, they build commercial airliners for the masses.
Yeah, well, Boeing shifted their entire business strategy away from radical innovation and moved toward incremental efficiency.
So just making what they have a little bit better.
Right. They became totally obsessed with fuel economy and stock buybacks. Building a supersonic jet requires taking massive R&D risks. Boeing just decided it was safer and honestly more profitable in the short term to just make slightly better versions of their existing fleet.
Okay, so there is this massive void. But I really have to push back here for a second because this is where the story sounds a bit, well, delusional.
Fair enough.
Skull steps into this void. He's a software engineer. His aviation experience is basically a Cessna pilot's license. And he starts, boom, with a cardboard and plywood mock-up of an airliner using seats they literally bought from Office Depot.
It's wild. Yeah.
If I'm an investor, I'm laughing him out of the room. Like, how did he convince anyone to fund this?
He faced immense skepticism, precisely because of what investors call the why now question.
Right?
It's this assumption that if a multi-billion-dollar idea is truly viable, surely a massive corporation is already doing it. And if it aren't, well, there must be a secret reason why it's impossible.
Bezos actually passed on Boom's seed round in 2015, didn't he?
He did, yeah. Jeff Bezos literally wrote in a shareholder letter that commercial airliners are something only big companies can do.
Wow.
And Skoll notes that the technology for Boom actually existed 10 years prior to him starting. The carbon fiber, the advanced software, it was all there.
But nobody did it.
Nobody did it.
You know, I always think of the why now question like surfers waiting on the beach for the perfect wave.
That's a good analogy.
Yeah, investors are out there looking at the weather, checking the tide, basically waiting for the universe to serve up the exact right conditions to justify a company's existence.
Right.
But Skoll's approach is more like, you know, bringing your own motorboat.
Yeah.
You don't need the perfect wave if you bring your own engine. Sometimes the answer to why now is simply because I started now.
That's a perfect way to look at it.
Mm-hmm.
The law of large numbers just doesn't always apply to startups. Sometimes great ideas just hide in plain sight, waiting for someone arrogant enough to try.
Yeah.
But, and this is crucial, to actually execute that idea, you need a radically different growth strategy. If you try to operate the way Boeing operates, but on a startup budget, you will fail instantly.
Right, which brings us to the crux of the business strategy. How does a startup actually hack hardware to behave like software? Because Skoll points out that the legacy aerospace industry is trapped in this total nightmare he calls spreadsheet engineering.
Spreadsheet engineering it's a structural bottleneck that just destroys speed.
How so?
Well, think about an airplane. It's a hyper-complex physical system where literally everything affects everything else.
Yeah.
If you decide to add one row of passenger seats, the fuselage gets heavier.
Okay.
If the fuselage is heavier, the engines need to be more powerful to push it.
Right.
If the engines are heavier, the wings have to be completely redesigned to generate more lift.
Oh, man. It sounds like, you know, trying to solve a Rubik's Cube where 10 different people are blindfolded and each person only controls one color.
Yes.
Every time you make a move, you ruin someone else's alignment.
Exactly. And historically, this was managed by teams of isolated engineering specialists, each working in their own siloed Excel files.
That sounds awful.
It is. The aerodynamics team runs their numbers, passes a spreadsheet to the propulsion team, who then run their numbers and pass it back. It makes the pace of iteration glacially slow and just prohibitively expensive.
So they basically just run out of money.
Yeah, they eventually just run out of budget, declare a design good enough, and start building it.
So Boom looked at this and basically said, this is just baby software being treated like a second-class citizen.
Right.
So they built a proprietary system called Make Boom. It lets them define an entire airplane in a single digital configuration file.
Yeah, that's incredible.
They hit run, and in just a few minutes, a script simulates the whole aircraft. Fuel burn, range, passenger capacity, all the physical trade-offs calculated instantly.
And this dramatically lowers the cost of iteration in the digital world before they ever even have to touch the physical world.
Right.
Because think about it, you cannot find product market fit on a supersonic jet by building 5 of them and seeing which one airlines prefer.
No, that's way too expensive.
Right. So Make Boom allows them to explore millions of potential aircraft designs to zero in on the precise one that maximizes the market opportunity.
And they built another tool called Blade Runner for the engines, right?
Yes. Blade Runner lets a couple of engineers tweak an engine turbine bleed design in real time and instantly see how it behaves aerodynamically and structurally. A process that used to take dozens of engineers, many months, is suddenly reduced to a few keystrokes.
But I mean, no matter how good your software is, eventually you have to leave the simulation.
Yeah, eventually you have to bend metal.
Exactly. You have to build the physical plane. And this brings up a massive issue with the aerospace supply chain. Skoll mentions he has, quote, no kind words for aerospace suppliers.
He's very blunt about it because the traditional supply chain is incredibly rigid, But there's a larger macroeconomic issue here, which is the loss of the tool and die industry.
Right.
In traditional manufacturing, if you want to make a carbon fiber wing or like a specialized titanium engine part, you need a custom precision mold, a tool to cast or shape that part.
And China essentially absorbed that entire industry over the last few decades. It's very hard to find large-scale tool and die engineering in the U.S. anymore. So how does a tiny startup in Denver beat that?
Through aggressive vertical integration and really adopting next-generation manufacturing, they just decided not to rely on an overseas supply chain that would inevitably slow them down.
Right.
So Boom built its own R&D machine shop in Denver. A facility Skoll notes doesn't even exist at GE or Rolls-Royce or Boeing, and they use an all-digital manufacturing process.
Wait, I need you to break that down. What does all digital manufacturing actually mean in the physical world? Because you can't just email an airplane part into existence.
Right, you can't. But they are using advanced additive manufacturing. It's essentially industrial 3D printing for aerospace-grade metals.
Okay, 3D printing metal.
Specifically, technologies like direct metal laser sintering.
Right.
You take a bed of titanium powder, and a high-powered laser melts the powder layer by microscopic layer based exactly on the 3D CAD file.
So they completely bypass the need for molds.
Exactly. Because there is no tooling, there is no mold to build or ship or wait for.
Wow.
They can go from a digital design on a screen in Blade Runner to a physical flight-ready turbine blade prototype in 24 hours.
Yeah, it is insane.
Right. If it fails a stress test on Tuesday, they just tweak the software and print a new one by Wednesday.
That iteration speed is incredible. But, there is a fatal flaw in this kind of speed.
What's that?
You can print a prototype blade in 24 hours, sure, but the FAA certification, the flight testing, the final build, that still takes a decade.
Oh, absolutely.
Which brings up the deal mechanics. How do you pay the light bill for a decade without selling a single airplane?
Yeah, in the venture capital world, this is known as the R&D desert.
The desert.
It's the graveyard of deep tech startups. It's incredibly difficult to raise financing when you know it will take billions of dollars, and you can't predict exactly how long it will take to reach revenue.
And the sources show Boom almost died in this desert. Skoll talks about his worst day, where Boom dropped to just 7 days of cash.
7 days.
7 days. The board literally advised him to shut the company down, but he refused.
And that near-death experience forced a strategic pivot that is just a masterclass in business strategy.
Right.
They realized they couldn't just wait 10 years for airlines to pay them for passenger jets. They needed a parallel revenue stream to survive today.
And because they made the choice to vertically integrate their propulsion, meaning they were building their own engines instead of buying them from GE or Rolls-Royce, they had an asset they could monetize now.
Exactly.
They took the core of the supersonic jet engine they were developing and adapted it for ground power generation. They created a natural gas-powered turbine called Superpower.
It's a brilliant tactical move because the core technology of a jet engine compressing air, igniting fuel, and spinning a turbine is fundamentally the same as a natural gas turbine used by utility companies to generate electricity.
Okay, yeah.
So by shipping Superpower as a standalone product, they solve multiple massive problems at once.
It reminds me of a startup trying to fund a multi-billion-dollar mission to Mars, right?
Okay.
And to survive the 10 years of building the rocket, they adapt their custom life support systems and sell them to deep-sea scuba divers along the way. It keeps the lights on.
That's exactly it. And for Boom, it does 3 vital things.
Okay, what are they?
First, running these turbines on the ground generates thousands of hours of vital test data. It proves the reliability of their engine core before it ever goes on an airplane.
Oh, that's smart.
Second, they get their first customer delivery in less than 12 months, which proves to investors they can actually execute and ship hardware.
Right. And third, which I think is the absolute holy grail for founders, it brings in non-dilutive R&D capital.
Yes.
They are generating real revenue to fund the airplane's development without giving up more equity to venture capitalists. They turned their largest cost center into a cash-flowing business.
Right. But even with the financing mechanism in place, Boom still faced a massive external roadblock. Flying a commercial jet supersonic overland was still literally illegal in the United States.
Right, the 50-year-old federal flight ban. I'm really curious how they tackled this because the tech industry has a very specific playbook for regulation.
Yeah, they do.
Look at Uber. Travis Kalanick completely ignored regulators. He just deployed the app, built a massive customer base, and then used those millions of voters as a shield against the taxi industry and local governments who were trying to shut him down.
Yeah, and Skoll explicitly brings up Uber, and he points out why that strategy is completely toxic for deep tech.
Why is that?
Uber's strategy made sense for them because the taxi industry was an entrenched enemy. They were using the power of local government to actively block competition. If Uber had asked for permission first, they would have been denied flat out.
But aviation is different.
Very different. It's safety critical. If you move fast and break things in aviation, people die.
Yeah, that's a problem.
Furthermore, Boom didn't have an entrenched enemy using the government against them. Boeing wasn't threatened. Skoll notes that Boeing just thought Boom was, quote, cute and would inevitably fail.
Okay, so Boom adopted a collaborative tactic. Instead of deploying and asking for forgiveness, Skoll went to the FAA very early on. He showed them the plans, explained exactly what they were doing, and explicitly asked the regulators to be part of the team. The mindset was Boom plus the FAA versus the problem.
And the regulatory return on that investment was just staggering. When it came time to get the flight permit for the XB-1, which is their test jet, they got it done in just 90 minutes.
Wait, 90 minutes?
90 minutes from when they submitted the final paperwork to the FAA actually handing over the permit.
That is unheard of. But getting a test permit is one thing. Overturning a 50-year federal ban on supersonic flight is another. How did they beat the subjective debate of, how quiet is quiet enough when it comes to sonic booms?
By using physics to bypass the argument entirely, they utilized a scientific principle called Mach cutoff.
Okay, what is Mach cutoff? How does that work?
It has to do with how the speed of sound changes based on temperature.
Okay.
In the lower atmosphere, down in the troposphere, the air gets colder the higher you go. But once you hit the stratosphere, it actually starts getting warmer again because of the ozone layer absorbing UV radiation.
Okay, so you have this layer of cold air sandwiched beneath a layer of warm air.
Right. And sound travels faster in warmer air. So if a jet flies at a sufficiently high altitude, right at that boundary, and hits the precise speed for those specific weather conditions, the sonic boom travels down into the colder air, slows down, and then hits the warmer air below it and speeds up again.
Okay, I'm following.
This temperature gradient creates a refractive index. It acts exactly like a lens. It literally bends the sound wave back upwards.
No way. It makes a U-turn in the sky.
Exactly. The sonic boom refracts upwards and never touches the ground.
That's amazing.
Yeah, Boom flew their XB-1 test jet and broke the sound barrier 6 times using Mach cutoff. And each time, there was absolutely no audible sonic boom on the ground.
Skoll compares it to a tree falling in an empty forest. If there's no boom at all, there's nothing for politicians to argue about. You've eliminated the problem objectively. And the speed of the regulatory change after this proof was incredible. Within 115 days of that flight, an executive order was signed making supersonic flight legal again, followed by unanimous bills in the House and Senate.
It just proves that regulations are not permanent physical laws. If you build the technology safely, demonstrate objectively why it's okay, and actually work alongside regulators, you can rewrite the laws of your industry.
Executing this multi-layered strategy, building software-driven hardware, pulling off creative financing, and rewriting federal regulations, it requires a very specific type of team.
Oh, absolutely.
And the aerospace industry hasn't exactly been a hotbed of startup talent. I mean, the last startup to successfully build a commercial airliner was Douglas Aircraft in 1921.
Over a century ago.
Yeah. So Boom had to do this with a tiny team. The entire XB-1 team was just 50 people.
50 people.
And those 50 people achieved the first independently developed supersonic jet, the first American-made supersonic jet in decades, and something really fascinating, the first augmented reality-only landing.
Yeah, I love this part.
I have to stop you there, though, because the first time I read that in the notes, I was incredibly confused.
Right.
Why wouldn't an airplane have a front window? Like, why do you need augmented reality to land?
It solves a massive hardware problem from the Concorde era. To fly supersonic, a jet needs a needle-sharp, elongated nose for aerodynamics.
Right.
But when the plane slows down to land, it pitches its nose up at a really high angle. That long, sharp nose completely blocks the pilot's view of the runway.
Ah, so that's why the Concorde had that famous droop snoot. It mechanically lowered the nose during landing.
Exactly. But that mechanical droop snoot was incredibly heavy, really complex, and prone to failure. So Boom used software to solve a hardware problem.
What did they do?
They removed the mechanical nose entirely, saved all that weight, And instead, they installed ultra-high-resolution cameras on the outside of the plane.
Oh, wow.
Yeah, the pilots wear AR headsets or look at screens that stitch those camera feeds together, giving them a perfect, unobstructed view of the runway right through the floor of the plane.
That is just like completely brilliant. And to build a team capable of doing that, Boom's talent philosophy is to completely ignore the legacy aerospace mantra that experience wins.
Right. Skoll calls it a lie told by big, stagnant companies.
Yeah, he argues that the moment you become a deep expert in a stagnant field, you are basically steeped in the past.
Yeah, you know all the reasons why something can't be done.
Exactly, which makes you essentially useless for building the future. So Boom targets early career talent, people who are brilliant and hands-on, but who haven't yet been indoctrinated by the slow cultures of legacy aerospace giants.
But isn't that like a massive risk? You're building a passenger jet. You can't just have a bunch of 24-year-olds guessing how fluid dynamics work.
Right, which is why they instituted what they call the Boom Rule.
Okay, what's that?
Young engineers are actively encouraged to design things they've never done before. However, if someone else in the world has done it, the Boom engineer is required to track that person down, call them, and listen to their advice.
But they don't have to take the advice.
Right. Nope, they don't have to take it, but they have to hear it. It perfectly threads the needle between youthful audacity and historical wisdom.
That's great.
And this ties back to a deeply personal lesson for Skoll about passion versus knowledge. He talks about his mom giving him some classic, well-meaning advice before he started Boom. She told him to, work on something you know something about.
Because his background was at Amazon. He had founded an app company that got acquired.
Right. So previously, he took that advice. He built mobile e-commerce apps because his resume said he was an expert in it. And he absolutely hated it.
He had no product vision, and he just didn't care about the outcome.
Exactly. The realization he had is that knowledge is just a commodity. Especially now, with AI and infinite resources online, you can learn the math, you can learn the engineering.
Yeah.
But passion, that deep irrational drive to see something exist in the world, that cannot be faked.
And look at your own career right now as you listen to this. Are you building something just because it's what you know? Or are you building it because it's what you actually want to exist in the world? Skoll learned that you can't really know what you're capable of until you pick a mission that inspires you and just give it everything.
And that passion is what gets a founder through the worst days, like when you have 7 days of cash left. You don't survive that if you're just building mobile apps you don't really care about.
You really don't.
So let's distill the core blueprints from everything we've unpacked today. If you want to scale the impossible in a stagnant physical industry, you need a new playbook.
Yep.
First, you have to treat physical atoms like digital bits, build the software tools, and use digital manufacturing like 3D metal printing to speed up iteration so you find product market fit before you sink billions into final production.
Second, you have to survive the R&D desert by building parallel revenue streams. You need to look for the superpower turbine in your business. The core technology you can adapt and sell today to fund the vision of tomorrow without diluting your equity.
Third, when it comes to regulation, if you don't have an entrenched enemy, partner with the regulators. Use objective data, like mock cutoff, to bypass subjective political debates. Make it you and the government against the problem.
And finally, hire for passion and audacity over legacy experience. Let early career talent break the rules as long as they listen to the people who wrote them first.
It's a comprehensive framework for attacking any problem that the world assumes is just too hard or too expensive to solve.
It really is.
Which leaves us with a final provocative thought. If a software engineer with a Cessna pilot's license can use digital configuration tools and modern 3D machine shops to build a supersonic airliner and in the process overturn a 50-year-old federal flight ban, what else is out there?
Yeah, think about the massive, stagnant physical industry surrounding us right now. Ocean freight, urban construction, the national power grid.
They are all lumbering along at the exact same speed they were decades ago. They're just sitting there waiting for someone to realize that you don't need the perfect wave and you definitely don't need permission to start.